welcome all to today's session on redox reactions. So today we are going to look into oxidation, reduction, and then we are going to understand what are redox reactions, and then types of redox reactions, and finally we will be able to justify whether the reaction is a redox reaction or not. So now the concept of oxidation. Oxidation, it has various concepts like addition of oxygen is called oxidation. Yeah. So if you take carbon, it reacts with oxygen and it forms carbon dioxide. So this is oxidation reaction. And if you take methane gas reacts with oxygen gas, you will get carbon dioxide and water molecule. So here of course carbon is converted to carbon dioxide by addition of oxygen, but at the same time what has happened, there is also removal of hydrogen that has taken place from methane. So removal of hydrogen is also oxidation. One more type of oxidation wherein if you take a coordination compound like K4FeCN6 and it reacts with hydrogen peroxide and it forms K3FeCN6 plus KOH. So in this case, if you observe the removal of electropositive element K plus is an electropositive element, right? So K4 is converted to K3FeCN6. So here removal of electropositive element has happened. So this is also a type of oxidation. And if I take another example wherein Mg reacts with F2 forms MgF2. So here what happens, fluorine, it's an electronegative element. So addition of electronegative element has taken place. So this is also an example for oxidation reaction. So, and one more example, that is Na, an element, if it loses one electron, it becomes Na plus E minus, that is an electron is lost and sodium is converted to Na plus. So here loss of electron has taken place. So all these are oxidation reactions. Now let's understand what is reduction. What is reduction? So in the case of reduction, just we can assume it to be opposite of oxidation. That is, if you take ethene, in ethene hydrogen is added to form ethane. So addition of hydrogen has taken place. So this is reduction. And if you take the example of HGO, here HGO decomposes to Hg plus O2. So here what has happened? Here HGO, removal of oxygen has taken place. And let me take one more example. FeCl3 reacts with hydrogen to form FeCl2 plus HCl. In this case, what has happened? Electronegative element is being removed. See, FeCl3 is converted to FeCl2. So the Cl minus removal has occurred here. So this is also a type of reduction reaction. And if you take HgCl2 reacts with SnCl2, it forms Hg2Cl2 plus SnCl4. See here, if you take HgCl2 is converted to Hg2Cl2, that is addition of the electropositive element Hg has taken place. So this is a type of reduction reaction. And if you take chlorine, it will gain electrons, 2 electrons, and it will form chloride ion. An ion will be formed. So gain of electrons is also called as reduction reaction. So when you summarize the oxidation and reduction reaction, it will be like this. So oxidation is addition of oxygen, removal of oxygen is reduction. Removal of hydrogen is oxidation, addition of hydrogen is reduction. Loss of electron is oxidation, gain of electron is reduction. And addition of electronegative and removal of electropositive is oxidation. Addition of electropositive or removal of electronegative element is reduction. And see here from neutral state, that is 0 to plus 1 or plus 2 or plus 3. It is oxidation. Here neutral state to, that is 0, neutral state to minus 1 or minus 2, then that is reduction. Or we can tell lower positive to higher positive. That means an element from plus 1 is converted to plus 2 or from plus 2 to plus 3, oxidation state. So that is oxidation. Higher oxidation state to lower oxidation state, that is reduction. That means from plus 2 to plus 1 or plus 3 to plus 2, like that if it happens, that is reduction. So we could tell increase in oxidation number like this, it is called oxidation. Decrease in oxidation number like this, it is called reduction. Now in this reduction, have you observed this reaction wherein I told Hg has become, that is addition of electropositives, reduction. Of course Hg is converted to HgCl2, that is addition of electropositive element, we call that as reduction. Now what has observed to SnCl2? See here, SnCl2 is converted to SnCl4, that is addition of electronegative element. So what is addition of electronegative element? That is oxidation. So in this reaction, one is being converted to, that is one is reduced, the other one is oxidized. Such reactions are called redox reactions. Okay, we have different types of redox reactions, but let us understand this in terms of oxidation number also. If you take HgCl2, I told you it is reduced, that is it is converted to Hg2Cl2. So if you observe the oxidation state of Hg here, it is in plus 2 oxidation state and it is converted to plus 1. That means reduction has occurred, that is higher oxidation state to lower oxidation state. And what has happened to SnCl2? SnCl2 is converted to SnCl4. That is, here Sn is in plus 2 oxidation state, it is raised or increased to plus 4 oxidation state. So here oxidation has taken place. So in terms of oxidation numbers, if you analyze, then you can easily find out which element is reduced and which element is oxidized. Here again I am telling you reduction, here from higher oxidation state it has gone to lower oxidation state, that is reduction. Here from lower oxidation state to higher oxidation state, that is oxidation. So if such reactions happen in a single reaction simultaneously, then we call them as redox reactions. Lot of examples in metallurgical industry or in biological processes, day-to-day life, we could see lot of redox reactions are happening. Now let's understand different types of redox reactions. Okay? And also we will see what which is reduced and which is oxidized in this case. So let's take combination reaction. I think you are all familiar with the combination reaction, wherein two elements or compounds combine to form one. For example, let's take carbon reacts with a simple example. Carbon reacts with oxygen to form carbon dioxide. Reaction you are familiar with. So let's take carbon reacts with oxygen to form carbon dioxide. So here both of them, they are in zero oxidation state. Carbon has gone to plus 4 and oxygen to minus 2. So what does this show? Carbon is being oxidized and oxidation has taken place, and oxygen from 0 to minus 2, here it has been reduced. So reduction of oxygen. So this is a redox reaction. Let's go for decomposition reaction. In the case of decomposition reaction, let's take an example. 2H2O decomposes to form 2H2 and O2. So here what is happening? Hydrogen in plus 1 oxidation state, oxygen minus 2 goes to 0, 0. Both of them in 0 oxidation state. So what has happened to hydrogen? From plus 1 to 0, it is reduced. and oxygen from -2 to 0, it is oxidized. Reduction, and here oxidation. So decomposition is a redox reaction, but not all the decomposition reactions are redox reactions. There are few examples like calcium carbonate decomposition where there is no change in the oxidation state, so that will not come under the category of decomposition redox reaction. Next, coming to metal displacement. Say for example, you are having copper sulfate and you are adding zinc metal to it. Zinc displaces copper and it forms zinc sulfate plus copper. So in this case, the copper is in +2, zinc 0, here zinc sulfate, so +2, copper 0. So see what happened, zinc 0 to +2 oxidation state. So oxidation has taken place. Copper from +2 to 0, so it is reduction, right? So this is a type of redox reaction wherein metal displacement occurs. And if you take the non-metal displacement reaction, for example, if you take sodium and it reacts with water. So metal with water, it will form hydroxide, sodium hydroxide is formed, and then hydrogen. So in this case, sodium from 0 to +1 oxidation state. So it's undergoing oxidation. And see, hydrogen from +1 to 0, it's undergoing reduction. So it's a non-metal displacement redox reaction. Next, coming to disproportionation reaction. So let's understand what disproportionation reaction means. Here, if there is simultaneous oxidation and reduction of same element takes place, we call that disproportionation reaction. For example, hydrogen peroxide, on decomposition, it is forming water and oxygen. So in this case, if you observe, in both the product we have oxygen. So the oxidation state of oxygen here is 0 and here it is -2. So here for hydrogen +1 and oxygen it is -1. So here also hydrogen +1, no change in hydrogen. But if you observe oxygen, first in this case conversion of water, it has gone from -1 to -2. That is, reduction has occurred, and -1 to 0 is also has occurred. So oxidation. So the same element oxygen is being reduced as well as it is being oxidized. So this type of reaction we call it as disproportionation reaction. Let's see one more example for disproportionation reaction. If you take P4, phosphorus reacts with the base in presence of water or aqueous solution, and it forms PH3 and H2PO2 minus. Okay, so here let's observe phosphorus. Here it is in the 0 oxidation state. So here it is in -3 oxidation state, and here it is in +1 oxidation state. You know very well to calculate the oxidation state of an element from a compound, so it's quite easy. So here what has happened to phosphorus? From 0 to -3, it has undergone reduction. And here if you observe from 0 to +1, so here it is being oxidized. Oxidation has taken place. See, same element phosphorus is being reduced and oxidized. Here the same element oxygen is being reduced and oxidized. Such reactions are called as disproportionation reaction. So these are all the different types of redox reactions: combination, decomposition, metal displacement, non-metal displacement, and disproportionation reactions. And next, let's answer this question, whether we are able to answer. Justify that the reaction of fluorine gas with ice is a redox reaction. We have to justify. That is, we have to observe whether there is change in the oxidation states of the element. Fluorine gas F2 with ice, that means H2O in the solid state. So this is in the gaseous state, this is in the solid state. So the reaction would be hydrogen reacts with fluorine to form HF, and it reacts with oxygen and fluorine to form HOF. This should be the reaction. So observe fluorine. Fluorine is in zero oxidation state. So hydrogen plus 1, oxygen minus 2. Here hydrogen plus 1, fluorine minus 1. Here what will happen? Hydrogen plus 1, oxygen minus 1. Sorry, fluorine minus 1, oxygen in the zero oxidation state. Right? So here fluorine has, that is fluorine is converted to, in both the cases, from 0 to minus 1. Fluorine in minus 1 oxidation state. So this means what has happened? Reduction of fluorine has taken place in both the cases, HF formation and HOF. But what has happened to oxygen? Oxygen in the minus 2 oxidation state, it has gone to oxygen with zero oxidation state. That means oxidation of oxygen has been taken place. So this reaction, reduction is also there, oxidation is also there. So this is, yes, this is a redox reaction. We can tell this, it is a redox reaction. So if you are able to solve this, then you are, I'm sure that you have very well understood this concept. Thanks for watching. Thank you.